Good morning, students. I am Suneetha, Assistant Professor of Chemistry from KGC Hanamkonda. Today we are going to discuss about second unit of first semester BSc. There the second unit is Organic Chemistry. In the Organic Chemistry we have two uh, topics. There the first one is Structural Theory in Organic Chemistry. So this is Structural Theory in Organic Chemistry. This is the first topic of second unit, that is Organic Chemistry. So let's discuss about organic chemistry. What is organic chemistry? Organic chemistry is nothing but the study of hydrocarbons and their derivatives. Study of hydrocarbons and their derivatives. Then what is meant by hydrocarbons? Hydrocarbons are nothing but the compounds of carbon and hydrogen. Exclusively carbon and hydrogen are present in the compound. That compound is known as hydrocarbon, and the study of these hydrocarbons and their derivatives. That is, the compounds which are obtained from these hydrocarbons are called their derivatives. The study of these hydrocarbons and their derivatives is known as organic chemistry. In the age of organic chemistry, then why we said like this? Because the three basic needs of human are food, clothing, and shelter, which are made up of organic compounds. Most of the medicines that cure diseases and relieve pain are all organic compounds. The LPG or cooking gas is a mixture of butane, isobutane, and to some extent methane. And gasoline propels the automobiles, the plastics, the rubber. These are all organic compounds which we use in our day-to-day life. So basic needs of humans are food, clothing, and shelter. These are made up of organic compounds, we said. So because of this reason, organic chemistry is more important. And in this basic needs, we come across all these medicines, LPG, gas, gasoline, plastics, rubber, etc. All these, they come under important organic compounds, which we daily use. So this is structural theory, our topic, structural theory, it gives a better understanding about the basic organic chemistry. So mostly organic compounds are covalent compounds because carbon generally forms covalent bonds. Now let's discuss about the types of the bonds formed by carbon. That is the types of the bonds we come across in the organic chemistry. So let's discuss about this covalent bond. So covalent bond is a chemical bond which is formed due to equal contribution and mutual sharing of electrons. So this is the definition of covalent bond. So what does it say? According to the definition, covalent bond is formed due to equal contribution of electrons and mutual sharing of electrons. Two atoms will participate in the covalent bond formation. This covalent bond is of two types. It is of three types, sorry. So first one is single bond, second one is double bond, third one is triple bond. The single bond is also called single covalent bond, and double bond is also called double covalent bond. Triple bond is also called triple covalent bond. Now let's discuss about all these types of covalent bonds in detail. There, the first one is single bond or single covalent bond. So what is single bond or single covalent bond? Let us discuss first. Single bond is formed by a pair of electrons are shared between the two atoms. That is, when one pair of electrons are shared between the two atoms, then that bond formed is known as single bond or single covalent bond. The best example for the single bond is hydrogen molecule. Generally, single bond is denoted by a small dash in between the two atoms. Now let's discuss about this. Let's consider one general example. Two atoms A and B. A contributes one electron and B also contributes one electron. And both these atoms, they share this one electron pair. Thus, a molecule AB is formed, that is denoted like this. So, a covalent bond is formed in between the A and B atoms, that is denoted by a small dash in between the two atoms, that is AB. So here AB molecule is formed due to equal contribution of electrons and mutual sharing of electrons between A and B atoms. Thus AB molecule is formed. This AB molecule has one covalent bond, that is single covalent bond, which is denoted by a small dash in between the two atoms. The best example, the simplest example we can explain for single covalent bond is hydrogen molecule. Now, one hydrogen atom contributes one electron, another hydrogen atom also contributes one electron, and this two electrons, that is a pair of electrons, are shared between the two atoms, two hydrogen atoms. Thus, H2 molecule is formed. That is denoted by H dash H. This dash is simple dash, a small dash in between these two hydrogen atoms is nothing but a single covalent bond. So this is about single covalent bond. If we consider methane molecule, there are four single bonds, four in between C and H, four single bonds are present. If we consider H2O molecule, in between oxygen and two hydrogen atoms, two single bonds are present. Similarly, if we consider ammonia molecule, in between nitrogen and hydrogen, single bond is present. So like that, these are all the different examples where single covalent bonds are present. Now, let's discuss about the double bond or double covalent bond. Double bond or double covalent bond. A double bond is formed when two pairs of electrons are shared between two atoms, and it is represented by two dashes in between the two atoms. So, double bond is formed due to the equal contribution and mutual sharing of two electron pairs. Two electron pairs are shared between the two atoms. Then it is a double covalent bond is formed, that is represented by a double dash in between the two atoms. Now let's consider few examples. They are the first and the simplest example is oxygen molecule. In between two oxygen atoms, there is a double bond. There is a double bond. This oxygen atom contributes to electron and this oxygen atom also contributes to electron, and the pairs are shared between the two oxygen atoms. Thus, O2 molecule is formed. In this O2 molecule, there is a double covalent bond in between the two oxygen atoms. Similarly, the other examples are carbon dioxide, where in between carbon and oxygen a double bond is present. This side also carbon and oxygen a double bond is present. Double covalent bond or double bond. Similarly, another example is ethylene molecule, that is CH2 double bond CH2, that is in between two carbon atoms there is a double bond. So this is about a double bond or double covalent bond. Now let's consider triple bond or triple covalent bond. A triple bond, a triple covalent bond. It is formed when three pairs of electrons are shared between the two atoms, and it is represented by three dashes in between the two atoms. A triple bond is formed when three electron pairs are shared between the two atoms. That is, equal contribution and mutual sharing of three electron pairs leads to the formation of a triple bond, we can say simply. And this is denoted by three dashes in between the two atoms. Here, let's consider the examples. The simplest example is nitrogen. In between two nitrogen atoms, there is a triple bond. This nitrogen atom contributes 3 electrons, and this nitrogen atom also contributes 3 electrons, and these 3 electron pairs are equally shared, mutually shared between the two nitrogen atoms. Thus, N2 molecule is formed. Thus, it is represented by N triple bond N. This is the triple covalent bond which is present in between the two nitrogen atoms. And other examples we come across the carbon monoxide, that is in between carbon and oxygen there is a triple bond. And one more example is acetylene molecule, that is CH triple bond CH. In between two carbon atoms there is a triple covalent bond. This is one more good example for triple covalent bond. So, till now we have discussed about the three types of the covalent bonds formed by carbon. Generally, carbon, it forms three types of the covalent bonds. There, the first one is a single covalent bond, and the next one is double covalent bond. Third one is triple covalent bond. A triple bond. Single covalent bond is formed when a pair of electrons are shared between the two atoms, and double covalent bond is formed when two pairs of electrons are shared between the two atoms, and a triple covalent bond is formed when three pairs of electrons are shared between the two atoms. Now let's discuss about the types of bond fission. Is defined as breaking of existing bonds in the reacting molecules. Generally, in the organic chemistry, uh, in this organic chemistry, what happens? The breaking up of the bonds and making up of the bonds takes place to form new molecules. So breaking up of the bonds is only known as bond fission. Bond fission. So in the existing reacting molecules, the old bonds must be broken and then only new bonds will be formed in the products. So here the breaking up of existing bonds in the reacting molecules is known as bond fission. This is definition of bond fission. And there are two types of bond fission. There the first one is homolytic fission and second one is heterolytic fission. So what is bond fission? Bond fission is defined as breaking of existing bonds in the reacting molecules. And this bond fission is the two types. The first one is homolytic fission, second one is heterolytic fission. Now let's discuss about each type of the bond fission in detail. First of all, let's discuss about homolytic bond fission. Homolytic bond fission. This homolytic bond fission, if the bond pair of electrons goes with both the bonded atoms, then it is called homolytic fission. That is, during the homolytic bond fission, what happens? In the pair of electrons, that is the two electrons, they are equally distributed to both the atoms. Then it is known as homolytic bond fission. So due to homolytic bond fission, free radicals are produced. That is, homolytic bond fission results in the formation of free radicals. Whenever homolytic bond fission takes place in a molecule, free radicals are produced. Then what is a free radical? Free radicals are nothing but the single electron or odd electron species, or the species or the atom with unpaired electron is known as free radical. I'll repeat. Free radicals are nothing but these are the atoms or group of atoms which have either one electron or single electron or unpaired electron. These are only called free radicals. Now, this when this homolytic bond fission takes place, that is, this homolytic bond fission takes place when two bonded atoms have same electronegativity. That is, if the two atoms having the same electronegativity, then the bond fission taking place in between the two atoms is only homolytic bond fission. So, homolytic bond fission, in homolytic bond fission, what happens? The two atoms which participate in the bond uh, with the two electrons which participate in the bond formation, they are equally distributed to both the atoms which are present in the molecule. Thus, we get free radicals, and this happens when the electronegativity of both the atoms present in the molecule is same. This is now let's explain this homolytic bond fission taking different examples. So, example here, homolytic fission, generally it is denoted by, it is represented by, let me say, fish hook arrow. Fish hook arrow. This is fish hook arrow. This is a curved arrow with one line here. So half arrow it is called. So this is known as fish hook arrow. Fish hook arrow is used to represent homolytic bond fission. Now let's discuss about the example here. Let's consider one molecule AB, which is made up of two electrons. A single bond is nothing but made up of two electrons. Now, the bond fission takes place, a homolytic bond fission. If it takes place in this molecule, what happens? One electron of this one goes to B, another electron of this one goes to A. Thus, we get A dot plus B dot. Dot is nothing but an electron here. So A dot plus B dot. So these are known as free radicals. What is free radical? We said free radical is nothing but the atom or group of atoms having unpaired electron or odd electron or single electron. So here A is a free radical, here B is also a. So let's discuss homolytic fission taking the specific example of chlorine molecule. Here chlorine molecule, it is made up of two electrons. This is single bond, single covalent bond, that is made up of two electrons. Now the homolytic bond fission takes place here. Then what happens? Two electrons, one electron goes with one chlorine atom, another electron goes with another chlorine atom. Thus we get two chlorine free radicals. Here star is also nothing but an odd electron, let me say. Odd electron can be represented by a dot or a star. So here chlorine free radical, another chlorine free radical. Now next example, let us see. This is hydrogen molecule, H2 molecule, which is made up of two electrons. The single covalent bond made up of two electrons. When it is homolytically broken, then what happens? So two hydrogen atoms, they get one electron each. Thus, we get two hydrogen free radicals. And next, one more example we considered here, that is bromine molecule. And between the two bromine atoms, there is a single covalent bond which is made up of two electrons. When this bond, covalent bond, is broken homolytically, then what happens? Each bromine atom gets one electron. Thus, we get two bromine free radicals. This is bromine free radical, another bromine free radical. So, these are the different examples for homolytic bond fission. So, what is meant by homolytic bond fission? We said homolytic bond fission, it is nothing but the bond fission where the bond pair of electrons, they go with the bonded atoms. The bond pair of electrons, they goes one pair of electrons, the pair of electrons, they goes with the both the bonded atoms. Then it is called homolytic fission. So due to homolytic fission, what happens? We get free radicals. So what is a free radical? We said free radicals are nothing but the atom or group of atoms. Group of atoms is also known as species. The atom or the species with odd electron or unpaired electron or free electron. That is only known as free radical. And generally free radicals are highly reactive because they possess odd electron. So generally whenever this homolytic bond fission takes place, we said the homolytic bond fission, it takes place when two bonded atoms have same electronegativity. Same electronegativity. Now, examples we have discussed here. Chlorine, both the chlorine atoms, they have same electronegativity. And they have same electronegativity. Whenever such type of atoms have same electronegativity, is producing free radicals. What is a free radical? We said free radical is nothing but the atom or group of atoms are the species with single electron or odd electron or unpaired electron. Generally, due to the presence of this unpaired electron, free radicals are highly reactive. Free radicals are highly reactive. And generally, homolytic bond fission is represented by a fish hook arrow. This one, fish hook arrow. This is curved arrow, half arrow. That is known as fish hook arrow. This is about homolytic bond fission. Now let's discuss about another bond fission, that is heterolytic bond fission. Now let's discuss about heterolytic bond fission. So heterolytic bond fission, if the bond pair of electrons goes with any one of the bonded atom, then it is called heterolytic bond fission. Heterolytic fission. In heterolytic fission, heterolytic bond fission results in the formation of ions, that is positive and negative ions. It takes place when two bonded atoms are having different electronegativities. So whenever in between the two atoms, the electronegativity difference is more, then what happens? Heterolytic bond fission takes heterolytic bond fission. Let's discuss here. Heterolytic bond fission, it is generally shown by a curved full arrow. This is normal arrow, let me say. Now, let's take an example, general example of AB. In between A and B, there is a covalent bond which is made up of two electrons, single transfer both the electrons towards one atom. The other atom becomes a positively charged ion, and this atom with the pair of electrons becomes a negatively charged ion. Then why this B is becoming negative ion and A is becoming positive ion means B is more electronegative than A. When B is more electronegative than A, then what happens? The bond pair of electrons, they go with the B atom. Thus, B becomes a negatively charged ion and A gets the positive charge. And this is a positively charged ion. In the other way, Here what happens, if the bond pair of electrons, they go with this A atom, then what happens, A becomes negatively charged ion and B becomes the positively charged ion. Why the pair of electrons are going with A? Because here A is more electronegative than B. This is how the heterolytic bond fission takes place. Heterolytic bond fission in the sense, the pair of electrons of a covalent bond, both will go with only one atom, the other atom suffers with a positive charge. Here these positive and negatively charged ions produced during the heterolytic bond fission of a covalent bond present in the organic molecules results in the formation of ions. Positive ions which are produced during the heterolytic fission are called electrophiles, and the negatively charged ions which are produced during heterolytic bond fission are called nucleophiles. So what are these here? Two types of ions are produced during the heterolytic bond fission. Positively charged ions are called electrophiles and negatively charged ions are called nucleophiles. Now let's consider the simplest example. Here we did not consider the carbon compound. As the simplest example I have taken, that is HCl molecule. If this in this HCl molecule, if the bond pair of electrons are moving towards chlorine, because chlorine is more electronegative, then what happens? We will get Cl minus ion and H plus ion. Similarly, another example, HOH, where O is more electronegative when compared to hydrogen. Because of that reason, this bond pair of electrons, they go with this OH, and we will get OH minus ion, and this H becomes the positively charged ion. Similarly, another example, let's consider this one, HBr molecule. In this HBr molecule, the bond pair of electrons, the covalent bond, single covalent bond, which has two electrons. These two electrons, they both go with the bromine atom. We will get Br minus ion and H plus ion. Here, the bond fission is taking place heterolytically. That is, unequal distribution of electrons. Homolytically in the sense, equal distribution of electrons. Here, unequal distribution of electrons is taking place. That is, only one atom from the bond pair, no electron is involved in with this atom. So this is how heterolytic bond fission takes place. And next, let us say the differences are the comparative study of heterolytic bond fission and homolytic bond fission. That is two types of bond fission. Comparative study, let us consider. So we have already discussed what is meant by bond fission. Bond fission is defined as the breaking of existing bonds in the reacting molecules. These bond fission two types we said there. The first one is homolytic bond fission and second one is heterolytic bond fission. Now here let us see the homolytic bond fission. In the homolytic bond fission, if the bond pair of electrons, they go with both the bonded atoms, then it is called homolytic bond fission. If the bond pair of electrons, they goes with the bond pair of electrons goes with any one bonded atom, then it is called heterolytic bond fission. So the difference between this and this is, here the bond pair is equally distributed, here the bond pair is unequally distributed in between the two atoms. And next one is distribution of free radical. What is a free radical? We said free radical is nothing but atom or the group of atoms, or it is also called species with odd electron or unpaired electron or single electron. And this heterolytic bond fission results in the formation of ions. So what are the ions produced? We said two types of ions produced here. One is positively charged and positively charged ions in this heterolytic bond fission are known as electrophiles, and the negatively charged ions produced during the heterolytic bond fission are called nucleophiles. Now, third one is this homolytic bond fission. It takes place when two bonded atoms have same electronegativity, whereas heterolytic bond fission takes place when two bonded atoms are having different electronegativities. This is about the differences or comparative study of two different types of bond fissions. And in this topic, what are the different questions we come across in the examinations? Let us discuss. Then the first one is define a covalent bond, discuss the types with examples. So First of all, we should define the covalent bond. Definition of covalent bond we should give. And how many types of covalent bonds are there? Each one we should mention. That's single covalent bond, double covalent bond, triple covalent bond, and about each and every covalent bond we should discuss. That is, define each and every covalent bond. That is single bond, double bond, and triple bond. Then give examples for each type. And next one is discuss the homolytic fission with an example. So, types of bond fission. What is bond fission and how many types are there? And there, the first one is homolytic bond fission. What is meant by homolytic bond fission? That is definition we should say, and followed by different characteristics or the how it is denoted and what are the different examples. Like that, we should discuss about homolytic bond fission. And next one is discuss heterolytic bond fission with an example. So, heterolytic bond fission, how this heterolytic bond fission takes place in between what type, what should be the electronegativity difference and how it is denoted, what are the different examples, all those we should discuss here in the heterolytic bond fission. So let us sum up the lesson, this part of the lesson. So here in the second unit, organic chemistry, we have started. There, the first topic is structural theory in organic chemistry, and second topic is acyclic hydrocarbons. Here today we are going to discuss about the structural theory in organic chemistry. So, in this structural theory in organic chemistry, first of all, introduction of organic chemistry. There, in the introduction of organic chemistry, what is meant by organic chemistry? We discussed. What is organic chemistry? I said organic chemistry is nothing but study of hydrocarbons and their derivatives. What are hydrocarbons? We said hydrocarbons are nothing but the compounds having exclusively hydrogen and carbon. Carbon and hydrogen exclusively when they are present in a compound, that is known as hydrocarbon. So what are the examples for hydrocarbons? Hydrocarbons examples: alkanes, alkenes, alkynes, they come under hydrocarbons. Alkanes means methane, ethane, etc. Butane, propane, isopropane, decene, like this. These are all alkanes. And alkanes, acetylene, ethylene. Ethylene is the best example, the first example of alkene series. Next one is alkynes. Alkynes, the first example is acetylene. Because of that reason, alkynes are also called acetylenes. Acetylene is CH, triple bond CH, that is C2H2. So there in all these examples only carbon and hydrogen are present. Therefore, because of that reason they are called hydrocarbons. So the study of hydrocarbons and their derivatives. Derivatives in the sense the compounds of this hydrocarbons. Example, let us consider alcohols, aldehydes, ketones, carboxylic acids, amides, amines. All these are the derivatives of hydrocarbons. So the study of hydrocarbons and their derivatives is only known as organic chemistry. So why we are going to study about organic chemistry specially? Because today we live in the age of organic chemistry. How do you say that we live in the age of organic chemistry? Because the three basic needs of human life are food, clothing, and shelter are made up of organic compounds. So because of that reason, organic chemistry has much importance, and we should learn about organic chemistry. So what are the different compounds, different organic compounds we come across in our day-to-day life? They're the medicines, LPG, gasoline, plastics, rubber. These are all the different organic compounds in our day-to-day life we come across. Next, this first lesson, that is structural theory in organic chemistry. It gives the better understanding about the basic organic chemistry. So, because of that reason, here before we are studying about this structural theory in organic chemistry. Mostly organic compounds are covalent compounds because in the organic compounds the so organic compounds are mostly covalent compounds. Now let's say the topics. There the covalent bond. Covalent bond. So what is covalent bond? Covalent bond is a chemical bond which is formed due to equal contribution and mutual sharing of electrons, we said. So both the atoms participating in the covalent bond, they contribute electrons equally and they share that electron pair, thus a bond is formed that is only known as covalent bond. This covalent bond is of three types, that is single bond or single covalent bond, double bond or double covalent bond, triple bond or triple covalent bond. Besides. Now next one is single bond or single covalent bond. How a single bond is formed? We said a single bond is formed when one pair of electron, a pair we said, that is one pair of electrons are shared between the two atoms, a single bond or single covalent bond is formed. So uh, examples for single bond or single covalent bond we discussed here, that is water, all these they contain single covalent bonds. When two pairs of electrons are shared between two atoms, are double covalent bond. The best example is oxygen, the simplest example we can say, and another example carbon dioxide, ethylene, CH2 double bond CH2, in between two carbon atoms a double bond is present. And next we discussed about the triple bond or triple covalent bond. Triple bond is formed when three pairs of electrons are shared between the two atoms and it is represented by three dashes in between the two atoms. The best example for triple bond is acetylene bond. Another example, simplest example I discussed here, that is carbon monoxide. In between carbon and oxygen, a triple bond is present. And one more is nitrogen, that is in between two nitrogen atoms, a triple bond is present. Next one is types of bond fission. In covalent bond, how this bond fission takes place. As bond fission is defined as breaking of existing bonds in the reacting molecules we said, and bond fission is of two types we discussed. That is, one is homolytic bond fission, and the second one is heterolytic bond fission. And homolytic bond fission we said, if the bond pair of electrons they goes with both the bonded atoms, then it is known as homolytic fission. If it and this homolytic fission is the formation of free radicals, and free radicals atoms are species with one electron or single electron or odd electron beside, and free radicals are highly reactive due to the presence of single electron beside. And it takes place when two bonded atoms have same electronegativity. The electronegativity of both the bonded atoms is same, then only the homolytic bond fission takes place. Here in the homolytic bond fission, equal distribution of electrons takes place. And homolytic bond fission, it is denoted by fish hook arrow. It is denoted by fish hook arrow. This is the fish hook arrow, half arrow. And here the bond pair of electrons are equally distributed between the two atoms A and B during the fission. Then what happens? We get A dot and B dot. Dot is nothing but an electron or odd electron or single electron. Here both the species they have single electron. Thus these are called free radicals. Examples we have given. Homolytic bond fission to form chlorine free radical, this chlorine molecule, and hydrogen free radical, and bromine molecule, it gives bromine free radical. We said the bond pair of electrons goes with only one bonded atom, that is unsymmetrical distribution of electrons takes place during the bond fission. Then it is known as heterolytic fission and it results in the formation of ions, and here the positive and negative ions are produced. The one with both the electrons becomes negative ion and the one with no electrons becomes the positive ion, and positive ions are called electrophiles we said, and negative ions are called nucleophiles. And this type of bond fission, that is examples, let us consider. Generally, this heterolytic bond fission is denoted by normal arrow we said, that is curved normal arrow. And here, example, AB molecule. Here, B minus and A plus ions are produced. Why B is having negative charge? Because B is having both the electrons of this bond, and when B is more electronegative if A is more electronegative than B, then what happens? The bond pair of electrons they go with A atom, and we will get A minus and B plus ion. Such type of bond. HCl, HOH, and HBr. Here, heterolytic bond fission of this molecule gives H plus and Cl minus ions, as Cl minus is more electronegative when compared to H, and in between H, OH, oxygen is more electronegative than and in HBr, bromine atom is more electronegative than H, and therefore H plus and Br minus ions are produced. And here we discuss the comparative study of heterolytic bond fission and homolytic bond fission. In homolytic bond fission, symmetrical distribution of electrons takes place, forming the free radicals. And here, unsymmetrical distribution of electrons takes place. Takes place when two bonded atoms have equal electronegativity or same electronegativity, whereas heterolytic bond fission takes place when the electronegativities of both the bonded atoms are different. That is covalent bond definition and types of covalent bonds. And next one is homolytic fission and heterolytic fissions with suitable examples. These are the and let's stay tuned for tomorrow's topic. Thank you all.